At some time or another, you've done it. One minute you're opening the mail and the next you're blindsided by pain radiating from a finger up your entire arm. You might scream a bit and even do a little dance of pain. It's intense and it takes a while to catch your breath. You look at your paper cut, so tiny you can barely see it. Well, that's embarrassing. No big deal, you think, as it stops throbbing. As it turns out, you're wrong. Your defenses have now been breached and your body is doing all it can to prevent you from getting sick or possibly even dying. According to Medical News Today, finger wounds that become infected aren't uncommon. After all, we use our hands for almost everything. They are constantly in and out of things, touching and feeling around for things. And from time to time, this means direct exposure to pretty nasty bacteria. Let's just say it's a good thing that germs are invisible, or we'd never get another night of sleep again, as we'd see them around us everywhere, literally covering everything. As it is, just because we can't see them doesn't mean they're not there. Each and every day, we're exposed to millions. One of the main ways our bodies keep them on the outside, where they won't make us sick, is through our skin. Unfortunately for you, you've compromised the system. Now, let's take a look at how the body's immune response kicks into gear in this type of a situation. When that razor blade-like envelope sliced your skin, your body was exposed to germs. And as we mentioned, there sure are a lot of them. The average person has anywhere from thousands to over 1 million bacteria on every square centimeter of their hands alone. And just because you got a paper cut doesn't mean that you're about to stop touching things, even some particularly germy ones such as door handles and faucets. So the odds were always that some bacteria would come right on in through the finger. Well, they did, and they're making themselves quite at home, using the welcoming environment of your body to start multiplying. They don't mess around when it comes to this either. Under the best conditions, a single bacterium will divide once every 20 minutes. That new bacteria will divide further. 1 becomes 2, which becomes 4, which become 8, and then 16, and so on and so forth without an end in sight. 7 hours later, and that 1 will have turned into over 2 million. Not to mention, typically more than 1 original bacterium will make it in. In other words, that first pesky intrusion will soon turn into a full-on catastrophic invasion. Once enough of the enemy bacteria are present, they'll begin to damage or kill the nearby cells of your body. Damaged cells send out chemicals that activate your body's response. The first thing to appear are macrophages, a type of white blood cell that arrives on the scene after squeezing through holes of nearby blood vessels. These cells do exactly as their name describes, though you have to know Greek in order to understand it. Translated, macro is Greek for big and phagian is Greek for eat. In other words, they're the biggest of the white blood cells and also eat quite a bit. They come to the scene hungry for bacteria as well as any damaged or dead cells. They engulf these by surrounding them and then destroy them with their internal enzymes. What's left after is released as waste. They also create a substance that attracts additional macrophages to the area. Each devours lots of bacteria in the same way, so they're quite a force to reckon with. Now, while all of this is going on beneath the surface of your skin, you'll know just by looking at your paper cut, it will start to appear a bit swollen. This is because of a fluid released by blood vessels to help the macrophages during their counterattack. Not only will your cut swell, but at this point, it may also start to feel very tender and hot when touched. Believe it or not, this is a good thing, as it means your body is doing what it's supposed to do to fight off that infection. Often, the macrophage-led defense will not be enough to solve the problem. Soon it may become clear that they need additional help when there are just too many bacteria. Fortunately, when your immune system is functioning as it should, assistance will soon be coming. Dendritic cells will activate, which really get things going. These strange-looking cells with a series of branching arms are continually exploring body tissues and looking through circulating particles to check on the status of your overall body. As pieces of bacteria are released by the macrophages as waste, a dendritic cell will encounter and ingest them. These are then broken into even smaller pieces, which it displays on its outer membrane. Every type of bacteria has a different structure and will create different pieces when broken apart. For example, pieces from the bacterium Staphylococcus will look different from those from the Staphylococci bacterium. Though both of these commonly result in infection, the dendritic cell will then go in search of a helper T cell. Each helper T cell can fight only one type of bacteria, and it needs to find the one that can attack the bacteria you're currently infected with. To know this, the right helper T cell will bind to the parts of the enemy bacteria on its surface. Think of the dendritic cell being covered with little locks and helper T cells having little keys. Each is made specifically for the other so that they fit together correctly. The wrong key won't work, And helper T cells for the wrong bacteria won't work either. When the dendritic cell finds the right helper T cell, they'll come together perfectly and a chemical reaction will occur. This activates that T cell, which is duplicated so that there are now many more of them. Some of these will go to the site of the bacterial invasion to help with the attack, while others go to seek a B cell that will again need to be specific for the bacteria you're fighting. Once these T and B cells find each other, the helper T cell will release chemicals called cytokines that activate the B cell. It will start replicating itself, and some of the B cells will then produce antibodies. These antibodies will help kill off the bacterial invaders. B cells work with impressive speed as they attempt to once and for all ward off the infection. The antibodies they produce enter the blood and spread throughout the body. These then attach to the bacteria so that they can no longer function correctly. After, they're engulfed by macrophages, as they've become easy targets with the attached antibody. In no time at all, once the full force of your immune response has been stimulated, the enemy bacteria should be gone. The body will then begin to repair itself. The cells created for the counterattack will die off, except for what are called memory cells. These are some T and B cells that match the bacterial invader that was just destroyed and will remain behind on standby. Should you ever become infected with the same bacterial strain again, these memory cells will remember it and launch an even faster attack to ward it off. This may happen even before any symptoms become noticeable, and is why many people get sick less often as they age. Their bodies have built up some immunity over the years to many potential pathogens. And that's how your immune system works in a very small nutshell, simplified quite a bit to make it more understandable. It's a very complex process with a bunch of different cells, tissues, organs, and chemicals, reactions, and interactions involved. The response for a bacterial versus a viral infection also varies somewhat, but in each case, every step is critical. After all, you need a fully functional immune system to survive, and even then there's a chance that things could go wrong. You may have thought we were joking when we said a cut could end in death, but we weren't. Unfortunately, it can and does happen. We've confirmed it through the words of doctors. These medical experts claim that when bacteria get the upper hand and a wound fails to heal, it can result in the loss of limbs or sepsis and death. It can all begin with what they term a seemingly minor skin infection. If you still aren't convinced even by a professional opinion, let's delve into a bit of recent history. In 2016, a man got a paper cut on his finger that eventually became infected. He developed sepsis and was given only a 50% chance to live. He could have been one of the around 250,000 Americans to die that year of that very same thing if he wasn't put into a medically induced coma. Because of that, he just barely survived. A young Australian also nearly died after he came down with flesh-eating bacteria from a paper cut he got while in his office. The next day, his hand was swollen, and within 12 hours, it had spread to his elbow. Soon, his doctors mentioned the words amputation and dying. They had to alternatively slice and vacuum away dead flesh to keep him alive. Now, the point of this isn't to get you to never open another envelope, as we're sure your bill collectors would be slightly less than understanding. It's merely to point out that what your immune system does is amazing, as every time you get even the smallest nick, scrape, or cut, without it, it can mean the end of your life. And that, despite our intentions, didn't sound any less terrifying. Let's just say paperless billing is always an option. So what do you think? Do you have a new appreciation for the wonderful things your body does every day to protect you? Will you ever look at a minor wound the same way again? Let us know in the comments. Also, be sure to check out our diseases that will kill you the quickest. Thanks for watching, and as always, don't forget to like, share, and subscribe. See you next time.